Today I'm going to quickly and practically go over a tool called nmap, or Network Mapper, and contrary to, I guess, popular lore, it's not just a tool for hackers. I actually use it a good amount for admin and software engineering type troubleshooting tasks. So let's get into it. We can use nmap with the command nmap, but today we're going to be running it privileged with sudo for reasons that I'll explain in the end of this video, but for now, we're just going to run it with sudo. You got to trust me on that one. Okay, so we can do that with sudo, nmap, and then a target. So let's talk about the individual scenarios in which you can use nmap. For this first scenario, let's say that I have individual computers on a network, and I'm individually on that network as well, and I want to see, what individual IPs are for the individual devices on this network. So you can do that with, in this case, nmap, and then a CIDR range. So I'm going to do that with 10.0.1.0 and then /24. This is going to basically look through all the IPs of the devices in the CIDR range. Now, there's one other thing we need to do here, and that is specify a scan type. And you can do that with -s and then usually an uppercase signifier. In this case, we're going to use an uppercase L for list. We don't want to actually fully scan all of these individual devices on our network. We just want to list them out. So we can do that with -s capital L. So let's run that. This is going to take a second. Okay, this actually is going to give us a few different things on our network. I'm not going to scroll through them all for reasons that are boring, but let's just grep out NixOS, because I know I have a system running on NixOS. So let's just see that one individual system. As you can see, nmap printed out nmap scan report for NixOS local domain and an IP address. So now that we have this IP address, a common task that we may do against an IP address is just ping it, right? You may have seen the command ping, and then we have 10.0.1.147. This is this pinging this individual Linux host that's in my network. As you can see, this is just sending an ICMP echo request. But we can actually also do this with nmap. So going back to nmap, and let me clear out this CIDR address, and then let's just specifically target that individual Linux host with 10.0.1.147. And then we don't have to use the scan list type. We can actually use the scan P, capital P type. And modern days, you'll also see this reported as -s-n. They're the same thing. Basically, what this does is going to send an ICMP echo, just like a ping command. But where this may be helpful instead of ping is you can use all the other power of the tool that we're going to get into, like CIDRs or DNS. There's other things that you can do here with nmap if you want to check if you have a connection to an individual system. But this isn't super powerful, right? You thought nmap did some other things. Well, the main thing that nmap does that you've probably seen or heard of is port scanning. So we can do that actually by not specifying a scan type, and this is going to do a default scan or -ss. Basically what this is going to do is try to establish a TCP connection on the 1,000 top ports that it's determined in its database, and it's then going to see if it can establish a connection with those individual ports. So let's see what this happens if we do sudo nmap and then the IP address of this device that we have on their system. A little bit more output this time than just the ping. If we look here, this is kind of the bread and butter of an nmap output. So it says a few different things about nmap, where it's scanning the IP address, host is up with the individual latency. Not shown is the 996 filtered ports, important, that's going to come back in a second. And then this display, basically it shows a port, these are this with the state open, and it's guessing the service that's running on that port, right? This is just doing a default check of like, what's the expectation of what's running on this port. In this case, port 22 is probably running SSH. We're going to go what the individual state means, but today, or at this very moment, we'll go over later in this video. At this very moment, we can say open means that basically port 22 is open. But like I said a second ago, this is only scanning 996 other filtered ports. This is only scanning 1,000 of the most popular ports. There's 65,000 ports. It would take forever for it to scan all of those ports against a remote system. But how would we specify if we wanted to, let's say, look at a port that we don't know if it's checking? So you can do that with the -p command and then the port that we want to scan. Let's say we want to scan port 2323. We can just hit enter. It'll be pretty quick. We see here port 2323 TCP is filtered, and then it makes a guess again for an individual port. Now, you can use this against a remote system. It can try to establish a connection and basically, try to start this TCP handshake. But in many cases, you may want to also check your local system to see if you can establish a connection, what ports are open on your local system. You can do that instead of specifying an IP, you can just say local host, and then you can specify the port range or leave it off to check those 1,000. In this case, we're going to do some special syntax, and that is just adding a dash right after that P. And this is going to check every single port, all 65,000 of them, and basically tell us which ports are opened in the state of each individual port. Now, this was a lot faster because it's on its own system. It's doing some things behind the scene. We're not waiting for the full network connection, so we can actually check all 65,000 ports in this case. And here we can see this shows everything that's open on this individual system. We have some things on 4317 and 4318. I can tell you I'm running open telemetry for a different video in the background. Yeah, and this basically checks all these individual ports that are open on this system. Now, here's the thing though. I mentioned that there's different states here. We're just seeing when it's showing opened or closed ports in this case, but there's a few different other scenarios. And to see those other scenarios or those other states that a port can be, we can actually take a look, and I'm not going to do port everything. I'm actually going to use the default scan type. So if we go sudo nmap, and then we can use the domain scanme.nmap.org. Now, this is a subdomain that nmap itself is set up that we can scan to see some kind of very different levels of output. So let's take a look at this. If we run this against that domain that I mentioned, we see a few other different states. We have that open state like we've seen before. Open means an application is actively accepting TCP connections on that port. We have what we don't see, 991 though, closed ports. A closed port is accessible. It receives and responds to nmap packets, but there's no application listening to it. But then we also have this filtered option. Filtered means nmap cannot determine whether the port is open or closed because it's being filtered or blocked by some sort of firewall or device or router or something of that nature. So it can't determine if it's open or not. There's also something you'll sometimes see here called unfiltered. An unfiltered state means that the port is accessible, but nmap is unable to determine whether it's open or closed for various different reasons. Now, you'll see some other like 5th and 6th states. One is open pipe filtered. Basically, nmap places these ports in a state when it's unable to determine whether the port is open or filtered. This comes into play when you're using other scan types than the one we're using today. Same thing with closed pipe filtered. Basically, this is a state when nmap is able to determine whether a port is closed or filtered. Again, you only see this with I think it's the for the documentation. Yep, IP ID idle scans. So not going to apply. The main ones is open, closed, filtered, and unfiltered state that you're going to sometimes see. But today we're mostly looking for open ports, and that's in this case is the state open. Okay, that's checking ports in this case. But one of the other things is it also can tell us about the stuff that's running on those individual ports. And we can do that with the scan type -S_V. And this is going to check the version, or basically it's going to check the software that's running on these individual ports and their version. So let's run that against, let's not do scanme.mmap. Let's just use localhost here. Now that this command is run, we see the same information we have over here. We have port 888 open. TCP, service HTTP, and then this version tab, we have Golang, net, HTTP server, and then basically some other information where it's guessing it's JSON, it's a Go server running or InfluxDB, right? It's making some guesses about the Golang service that's running here. I can tell you this is just a simple Go file that's running here. So although this shows us this extra information, we're kind of back to the limitation we had before, where this only is going to do the top 1,000 ports that it's checking for here. So if we wanted to look at ports outside of that range, we would still need to specify the -p or the port command. In this case, if we want to check everything, we do that with -p again. Now this is going to take a second. If we while nmap is running, you actually have a little bit of things you can do. You can change the verbosity and debug values. You can see what you can do with while this is running with shift ? Or just basically running ? You're going to see that you can just change the verbosity and debugging information. I'm just going to tap V a few times, and it's going to change the verbosity on this, so we can actually print out more information as it's running, because this is going to take a while. But let's let this run. Partially because I turned up the verbosity, but partially because this command itself is going to spit out a lot of information. We finally have the results, but there's just a lot here. So if we scroll up through all of these fingerprints, we can see here's all the open ports again, and here's all the guesses for the individual software and the software versions that's running on each of these individual things. Again, this is all Golang, different things. This was open telemetry running in the background, so the Golang makes sense. The other information we can get about an individual host is the operating system and potentially some operating system information as well. So we don't want to use localhost here. We can use the command -o, and let's go back to that Nix OS box that we have running on 10.0.1.147. Let's use the -o command. Actually, sorry, I'm looking at this now. I'm thinking this has to be capital O. Let's run this. So as you can see, the output here, it's all the same stuff that we've been getting before with the port information. But we also have these OS scan results down below. Now, this had a little bit of a hard problem guessing the operating system, mostly because it says it didn't find at least one open, one closed port. As you can see above, we actually have filtered ports instead of open. That means there's some sort of firewall that's blocking this access. But it's still taking a guess, right? It's thinking it's probably Linux. We can wrap up some of this version detection and operating system detection with the -a command. So if we actually run... Let's say we run this against our local host. We can do that sudo nmap -a. You'll also hear this referred to as aggressive localhost. Let's just run that. So this actually gives us some new results. We still have the closed and open ports information. We have the information about the Golang server that's running, or at least its guess. It's also doing some kind of requests here. It assumes this is Linux.26. Yeah, here's some more kernel information, and then it also gives us some trace route information, in this case 0 hops. Another thing I want to show with nmap was the different ways you can output information. Now, you have the standard output when you just run nmap against, individual device, but sometimes, let's say you want a little bit more information about when and how it ran, and let's say you actually are putting this into a file for consumption later, you can actually specify the output that nmap uses with a few different options here. You can use -o and then a capital letter to specify the output. In this case, if we use capital N for normal output and then we give it a file, let's just say out.txt, it's going to run nmap. It's still going to print to the screen, but it's also going to show it in out.txt. And in this case, it has a little bit more information. It says nmap, the version. It gives a timing and the command that was actually run to give us a little bit more information. Instead of just the OM, though, we actually have a few other options here. For example, if we use OX, this will be XML output. And if we use OS, S stands for script kiddie output. So let's type in script. Let's have a new file called script out. It's going to post to script out. And if we look at that script out, we have basically leet speak in here, like script kiddie. Yeah, if you want your files to look like this, you can do that. That was the main ways in which I use nmap. Now, there's a few other things that you should look up if you're curious. Now, their man page for nmap is amazing. I recommend reading it through front to back if you care about computers. The sections about firewall ID evasion and spoofing is interesting, especially about script input, using scripts to help nmap and kind of power it up. And then lastly, the SI command. Okay, next day Kevin here, because I really wanted to make sure I explained this properly. This is on how nmap works under the covers and why it needs to be privileged to actually operate efficiently, even when looking at a remote system, not even introspectively looking at your own system. Here I've drawn out a TCP, a traditional diagram of a TCP three-way handshake. Client sends an SNY, SYN, server replies back with a sign awk, and then the client replies an awk. This is the three-way handshake. You see there's 3 steps here. Now, if we run sudo nmap ss, this is the default scan, right? You don't even have to do ss, but the default scan, nmap actually doesn't do this three-way handshake. What it does is it sends the initial SNY request. The server may reply with a few different options, right? Because we're checking to see if this port is even open. So if it's not open, right, the server might reply with a RST, which is a reset. Can I just type RST here? And this basically is how nmap knows that that port is closed. Now, if the server actually appropriately replies with the sign awk, what nmap then does is it replies to the server, not with an awk, but with an RST. So we can ignore this awk, keep calling it awk, right? Nmap will then respond with this reset. So basically this is also called a TCP half open, because it's starting to establish a connection before it actually does establish the full connection. It sends a reset and it doesn't actually fully connect. Some benefits here is the idea that back in the old days, this isn't really true today, but maybe your firewall won't fully log the connection because it wasn't a three-way handshake, right? That's not as true today. Advancements and all that tooling has come a long way. They know what nmap is, for example. But the other thing is you don't have to wait for the full TCP connection. The thing is these are raw TCP packets, and this is done by the kernel. So to have access in kernel land to actually evaluate these TCP packets is why you need Pseudo. Now, nmap still works without doing this, without the privileged execution, and it does that by actually still letting the kernel complete the three-way handshake. So it doesn't know about the sign awk. It just tells the kernel, right, nmap in an unprivileged state says, hey, connect to the server on this port. And then it has to wait. It has to wait for either a timeout or the reset command comes and the kernel handles that. And actually, nmap would only receive, right, connected or error connect. It doesn't actually know the extra information like that RST, that reset that it would have gotten if it had that access to see that TCP packet. Now, some downsides here, again, it goes back to you're fully establishing a connection. This takes a lot longer because you're waiting for a timeout potentially. You don't have full understanding of why there was an error connect, right? You're just trusting the kernel in the sense to say error. You assume that there was a reset, but there could have other things at play that you don't have access to. So yeah, that's a little bit about behind the scenes of how nmap works, why you have to run it with execution, because it needs that extra ability to manipulate TCP packets. So yeah, that's nmap. Hope you found this little explanation helpful. This mattered a lot more back in the day when nmap was at its infancy, where you'd have shared sessions where you'd go to your computer library and you would shell into you would have a user and you wouldn't have, let's say, privileged access. But now, I mean, pretty much all the time you'll be operating on an as system that you have Pseudo, I'm guessing. So it matters a lot less. So just run it with Pseudo. Now, if you're curious about any more of the nmap man page is actually amazing. It's fun, it's well written, and it's easy to digest. So they actually explain a lot of this in that man page, so I encourage you to take a look to really level up your skills with nmap, including learning a few extra flags that I maybe didn't mention, like I didn't even touch on UDP, for example. Okay, well, other than that, have a good day, and talk to you later.